All right, I'm going to see how this works. If I sound really distant, it's because I am very distant. I am recording on a smartboard, so I apologize for this poor quality video. But hopefully this will help with my students that I will not be here once again going over a review on how to do derivatives of logs, exponentials, and arc and inverse trig functions. All right, so without further ado, little review. All right, so I'm going to go through a couple problems and see how we do it here. So you'll see a problem like this, and we're going to find the derivative of each one of these. Okay, and we're going to start out with, we're going to have, like, I don't know, let's say we have e to the 5x, all right, and we have cotangent of 7x. Find this derivative. So if you want to stop and do this first, and then press play to make sure you get it right, go right ahead. All right, you're back. All right, so we got y prime. Y prime is going to be, we're going to use the product rule. All right, so make sure you do the product rule. All right, we're going to take the derivative of e to the 5x, which is 5e to the 5x. So the derivative of e is 5x, and then we have the derivative of the exponent is 5 times the cotangent of 7x. We're going to add that to the derivative of cotangent. Now, cotangent derivative is going to be negative cosecant of 7x, squared of 7x, times the derivative of 7x, which is 7. All right, and we're going to multiply that by e to the 5x, and that is what we have here. All right, and that's our derivative. If you want to factor out e to the 5x, go right ahead. We have e to the 5x. We have 5 cotangent of 7x minus cosecant squared of 7x times 7. I'll put that right there. And that is going to be our derivative. All right? Good? All right, let's try another one. Next one, number 2. Let's say I have this. Let's get into a little arctangent kind of action. All right, let's say I have arc. All right, let's go cosecant of x squared over 4. X squared over 4. All right. We're going to find the derivative of this, once again. And it's very important that you understand what the inverse trig functions are. So we have the derivative. We're going to take the derivative of the outside. All right. Derivative of our cosecant is going to be negative 1 over, and cosecant, we're going to have our absolute value of our function inside, which is x squared over 4. All right. Times the square root. And we're going to take our square root, and we're going to have x squared. Now, in this case, we have x squared over 4. That quantity is going to be squared, minus 1. We then need to multiply this by the derivative of the inside. Our inside function right here is going to finish the chain rule. Make sure you use the chain rule, okay? The inside function is going to be 2x over 4, all right, which we know we can simplify, all right, to just 1/2, all right, x, and I'll do that right now, 1/2 x. All right, and that would be our answer. Okay, oops. All right, and that's our answer. We can simplify a little bit farther, but we'll just stop there. But that's how we set it up. All right, okie dokie. Let's do another one. Number 3. Once again, if you want to try these out, all right, on your own. So just pause the video and you can do some of these. All right, let's say we have 7x to the 4th minus 3x. We're going to find the derivative of this function. Okay, these are really crazy, and just a little review. Make sure when you have other bases than e, all right, the derivative of a to the x is a to the x natural log of a. So we're finding this one right here. We're going to take y prime. We're going to take the derivative because it's exponential. 3 to the 7x to the 4th minus 3x. So we have the derivative of that is going to be 3, 7x to the 4th minus 3x, times the natural log of 3, because that's the base. And then we have to finish the chain rule. Remember the chain rule. All right, chain rule. We're going to take the derivative of the top function. So in this case, we're going to have 28x to the 3rd minus 3. Here we have it. And that's our function. Okay? Let's use the exponentials. All right? Let's try another one, shall we? Why not? All right. Let's go through, and we have number. Oops. Let's be on 4th. All right. In our 4th one, let's say we want to find dy dx again. We have y equals. Let's go. Once again, let's go inverse sine of 9x plus 8. All right, there we go. Very similar to the one we just did a little while ago. All right, but here we have the inverse sine. All right, inverse sine is the same thing as saying arc sine of 9x plus 8. We have y prime. We're going to take the derivative of arc sine. Arc sine is going to be 1 over the square root of 1 minus our inside that quantity squared. Now our inside here is going to be 9x plus 8. We're then going to take the derivative times the derivative of the inside. Remember the chain rule. The chain rule states we now have to take the derivative of our inside function. So right here, we're going to take the derivative of that, which is equal to 9. We can obviously simplify this. It's not too bad. All right, 9 over the square root of 1 minus the quantity 9x plus 8, the quantity squared. We could simplify the bottom, but I'm not going to. That's our answer. So make sure we know our inverse trig. This will be very, very important. Let's do another one. Now, if you just write all these down, I'd probably just try some of these on your lonesome. All right, we have that. All right, so let's try this. Let's say I have, all right, y equals, we'll have 3x squared times e to the 10x, something like that. All right, of all these, we're going to find y prime. Very common one you see all the time, very similar to what we did before. All right, so I consider an easier one. So remember, we're going to use the product rule in this case. Sometimes students say, well, aren't we using the chain rule? Yeah, we're using the chain rule, but we're starting with the product rule. We have this function times this function right here. So y prime is going to take the derivative. We're going to be 6x times e to the 10x plus the derivative of e to the 10x, which is, remember, e to the 10x times the derivative of 10x, which is 10. All right, times 6x. That's our second. This would be our answer, not simplified. We can factor out e to the 10x if you wish. We have 6x left over. We have plus 60x right there. All right, and if we are so inclined, we can write it as e to the 10x. Oops, that would be, is that right? Probably, hopefully, some of you stop me. Say, you didn't do that, right? You have 3x right there. That makes a lot more sense. All right, and so then what we have is 30x squared, and there we have our answer. Okay. All right, make sure you take that. That's the second one. All right, that's where we get that. Okay. So be careful. You're doing it. Okay. Okie dokie. Let's do a couple more. Just a couple more. All right. Let's say I have number 7. I have y equals y base 7 of the quantity 3x over x squared plus 1. All right, to do this, we're going to take y prime. Recall, just like when we had the other one with a base other than e, we have y log base a of x. The derivative is going to be 1 over x natural log of a. We have to take the natural log of the base. All right, natural log of the base. So here, we're going to take the derivative of log base 7 of 3x over x squared plus 1. And I'm going to pause this real quick because there are people going to be. And I'm back! But for you, you probably never thought I was gone. All right, so here we go. We're going to take this derivative. So we're going to take the derivative of this, which would be 1 over 3x over x squared plus 1 times the quantity natural log of 7. Now, this is a way we can do this. We're going to now use the quotient rule. All right, so we're going to take the derivative of the top, which is 3 times x squared plus 1, minus the derivative of the bottom, which is 2x, times the top, which is 3x, all over the bottom squared, x squared plus 1, that quantity squared. Now, there's another way you could do this, if you so choose, is that since all of this right here is a log, we can use the property of logs to make this a little bit nicer. Log base 7 of 3x, we can add that to log base 7 of the quantity x squared plus 1. To this one, we can actually take, we have 1 over, all right, 3x times natural log of 7 times the root of that, which is 3. So we can cancel out. All right, plus we have 1 over, all right, x squared plus 1, that quantity, times natural log of 7, times the root of the top, which is, or in the inside, I should say, which is going to be 2x. And this would be a simplified answer where we'd have 1 over x natural log of 7 plus 2x over the quantity x squared plus 1 natural log of 7. And it's really small right there. All right. But two different ways of solving the same thing. Both give you the same answer. This one right here is more simplified. All right. But both are equivalent, all right, to getting correct. All right. I'm going to do one more, the test of distance, the theme. All right. And hopefully this will serve you well. But we're going to find what is the derivative of when you have y equals x to some sort of power. Let's go like cosine of 5x or something like that. All right. Here we have a base, which is x, an exponent, which is x. Now, in order to solve this, we're going to use logs. Now, don't use this for many other ones. You can use this for other ones when you're trying to solve for exponentials. All right. All right. And so we're going to use our logs. So we're going to log both sides. We're going to do the log of y. All right. We're going to do the log of the other side as well. Okay. Now, this is where these properties of logs for good and not for evil, people. Okay. So when you use it for good, you're going to take this exponent, because it's inside the log, you can put that to the front. So now we have cosine of 5x, natural log of x. That is using logs in algebra for good and not for evil. Okay? We do not use, well, we can use logs for other exponentials, but this is where you want to primarily use it, is when you have a base, which is a variable, and the exponent is a variable in the same problem. Okay. So now from here, we are now going to take the derivative of this. So now we're going to differentiate it. That was our goal, even though I didn't write on that, but this whole entire video is on differentiating, so hopefully you got that. Now, from here, we're going to get the derivative of natural log of y, which is 1 over y, because that's what the derivative of natural log is, times y prime. Oh yeah, my jokes keep on coming, even on videos. All right, so then you take the derivative of cosine of 5x, which is negative sine of 5x, times the derivative of the inside, which is 5, times natural log of x. We have to use the product rule here. Product rule right there. Okay. Plus now the derivative of natural log of x, which is 1 over x, times cosine of 5x. All right, that wasn't too bad. And now the last thing is we're going to get y prime by itself. So we're going to multiply both sides by y, because we're going to get y prime by itself. All right, so we have right there. And we do that, cancel out. Pew, pew. Sound effects when appropriate. And now we have negative 5 natural log of x sine of 5x. I'm just kind of rearranging this a little bit. Plus cosine of 5x over x times y, which is, well, look up here. Our y value is actually x cosine of 5x. And so, my friends, bada bing, bada boom, that is your answer. Ta-da! All right. So I hope this serves you well. All right. Went through a lot of different problems. You go through some additional ones. All right. But, all right, make sure you know how to do arctangents. Make sure you know how to do some exponentials. All right. And logs. All those are always so fun. All right. So good luck. God bless on the rest of your problems.